What's up, guys? It's Mr. Wicklehouse, and I'm coming at you today to talk about conics. This will be the only video on this section, so we're going to have a lot to cover on here. But as long as you take your time and take good notes, you should be fine. So conics are circles, parabolas, ellipses, and hyperbola. Alright, let's get started. So what are conic sections? Conic sections are cross sections cut out of a pair of cones stacked on top of one another. So you can see right here we've got a couple cones, they're stacked up, and you're just essentially, it's like taking a piece of paper and just slicing through it. So if I slice through like this, so that I'm just cutting through one, I get my fancy parabola or my quadratic. Circle is just across, straight across, horizontal cross section, and there's your circle. An ellipse is if you kind of tilt it a little bit, and then it just elongates that circle. And then a hyperbola has it's like two parabolas across from each other. Okay. The two most commonly worked with conic sections are circles and parabolas. I'm sure you're all very familiar with parabolas with all the work that we've done on quadratics this semester and in the past. And then you're probably pretty familiar with circles as well, considering the fact there was a whole section of it in your geometry class. The other two, they aren't quite as common, but they still pop up quite a bit, especially in physics and astronomy, that kind of stuff, where you're talking about ellipses and hyperbolas. Okay. Alright. So if we're working with conic sections, there's really only one thing that you need to know how to do in order to get it in the appropriate form so you can get all the information about it. I said it was the only way, but it's not really the only way to work with conics, but it's probably the hardest part. And if you guys remember from working with quadratics, you have to be able to complete the square. A lot of times a conic section is given to you in a form like this, where you've just got a bunch of x's and y's, and there's the two squared parts and so on, and you have to combine stuff together and do a bunch of work in order to get these things in the form that they need to be in. Okay. So let's just review completing the square real quick. So if I was to give you an equation, x squared plus 6x, remember that we're taking half of b, so b is 6. And then I'm squaring that number. So 6 divided by 2 is 3, square that, and I get 9. And then we add it to our equation, but because we're adding it, we're also subtracting it. Or if you have a situation where you had like x squared plus 6x equals 3, or 0, or whatever it may happen to be, and we added 9 over here. In the past, we also added 9 over here, and that was another way that we went through and did that. But in any case, so we do that, we factor this part of it, and get x plus 3 squared, quantity squared, minus 9, and that's all there is to it, to completing the square. If you guys need help completing the square, come and talk to me about it. Alright. Completing the square with conics. The thing that makes this difficult with conics is that most of the time you have to complete the square twice. So for example, if I've got an equation in this form, y squared plus 2y plus x squared minus 6x equals 12, I'm going to have to complete the square twice with my y terms and with my x terms to get it in a form that I'm going to like. So what I'm going to do, and the easiest thing to do, is kind of group your y's and your x's together. If they're not written together like they are in this form, just move them around, make sure you keep the signs and stuff with it so that they're grouped together appropriately, and then you're going to go about completing the square. You're going to look at it like it's two separate problems. So we'll look at the y, and then we'll look at the x. Okay. So to complete the square with the y, then I'm going to take half of b, which is 2, so that's 1, and square it, and then add it. So 1 squared is 1, so I added that. Not only did I add that here, but because I have the number over here, I also added a 1 to the 12 on that side. Okay. Now I've got -6 for b for the x's. I'm going to take half of that, get -3. I square -3, and I am adding 9 here. So because I added 9 over here, I added 9 here. Okay. So now that I've got that, I'm going to take my y's and I'm going to factor them. And this is just y plus 1 quantity squared. Take my x's, factor them, x minus 3, because I need to get the -6, quantity squared. And then 12 plus 1 plus 9, that's 10 plus 12, which is 22, and you're done. So this is the biggest, hardest part of doing conics, is you have to be able to complete the square. Again, if you don't remember how to do it, then come and talk to me about it. The other thing about doing this too is make sure you group your same variable terms together. It'll help organize your thinking and make it easier to complete the squaring on that. Alright? Alright. Let's take a look at circles. So we've completed the square, we've done everything that we needed to do to get it in the form that we want, and this is the form for the circle right here. So you might remember that from geometry. It was talked about in your geometry class. We got x minus h squared plus y minus k squared equals r squared. H, this value here, is the x value of the center of the circle, and k is the y value of the center of the circle. Remember that if there's a negative here in the middle, then it's the opposite sign. Negative here, it's the opposite sign. If it's positive, then it's going to be negative, all that kind of stuff. R is the measure of the radius of the circle. We've got r squared. You're going to take the square root of r squared to get r. So remember that the center of your circle is here, hk, and the radius is r. Okay. So let's look at an example. So after you've, whatever form they put it in, you've completed the square, and it looks like this. You've got a plus sign in the middle. You've got some number over here. There's nothing weird looking about it. You're just going to identify the center and the radius. So identify the type as well. Because it's in this form, added, nothing outside of the parentheses. This is 22. This is a circle. Okay. It's a circle here because the first thing I do after I complete the square is look for fractions. There are not any fractions, so I know that it is not an ellipse. Typically, if you have an ellipse, it's going to have some kind of fractions in it. Then I decide to see how many square terms I have. There are 2 square terms, so it's not a parabola. Parabolas only have 1 square term. Lastly, I look to see if there is subtraction. There is not, so it is not a hyperbola. If this was minus in the middle, it would be a hyperbola. So it must be a circle. So identify the center and the radius. Be careful here because the x and y are reversed. In other words, they're the opposite signs. Also, the y value is coming first and the x value is coming second. If I wanted to rewrite this, I could just move that in front and move that behind. So here's my 3. So my x value is 3. My y value, remember, is opposite sign, so it's -1. And then I just take the square root of the rate of this number here, which is 22. So square root of 22, it doesn't simplify at all. So the radius is the square root of 22. Okay, so that is a quick rundown on how to do circles. Now let's look at parabolas. I'd say parabolas are the most common conic section. They show up all of the time. We've done tons and tons and tons of work with parabolas. There are 2 forms of parabolas, one that opens horizontally and one that opens vertically. So sometimes they'll look like this. Sometimes they'll look like this. You guys have never worked with them when they're opening horizontally or opening in this direction or that direction, because these are not functions, and these are the most common that we use because they are functions. So vertical parabolas are conic section where the x value is squared and the y is not. So you're going to have an x value squared, and the y value is not going to be squared. If you see only one value squared, whether it's x or y, then you know that it is a parabola. Horizontal parabolas have the y values quantity squared. Okay. Got x minus h squared equals 4p times y minus k. For vertical, and the horizontal is y minus k squared equals 4p times x minus h. Vertical, horizontal. When I'm trying to work with parabolas, I need to be able to identify the vertex of the parabola, which is very similar to the center of the circle where we've got h and k. So h is the value that's with the x, k is the value that's with the y. That does not change. So the vertex, this point right here, the lowest point on your curve, is identified by h and k in the same way that it's identified with the circle. There's something else, a little imaginary point inside of your parabola, and it's called the focus. Okay? So in order to identify that, depends on whether it's vertical or horizontal. For a vertical parabola, to find the focus, you just take your vertex and you're going to add this p value here to your y value, because it's just inside of the parabola, so it's going to move up. If it was negative, it would be moving down, and this would be a negative p. For horizontal, you're moving to the right or to the left, so you're adding p to the h value. Something else called the directrix. This is an imaginary line that helps define the parabola. The directrix and the focus are tied together. They're equidistant from any point on your parabola. Okay, that's the relationship, and those points make up your parabola. You don't really have to remember that. I'm more concerned with you being able to identify it. You'll work more with this stuff in pre-cal if you were doing that. Okay. So in order to find the directrix, remember it's a line, so you have to write the equation for a line. And you're going to write that as y, for vertical, as y equals your k value minus p. So it's going to be y equals some number, and that's going to be this line. If it's horizontal, your directrix is going to be down here somewhere or over here. It's going to be a vertical line, so you're going to be subtracting p from your h value, or your x value rather. Also something to keep in mind for vertical parabolas, if p is positive, so this number right here is positive, then the parabola opens up. If p is negative, the parabola opens down. For horizontal parabolas, if p is positive, then the parabola opens to the right. If p is negative, then the parabola opens to the left. Alright, let's do an example. So, we've completed the square, we've got everything in this form. It says determine the form of the conic, then identify the center and radius if it is a circle, the vertex and focus if it is a parabola, the center if it is an ellipse, and the center if it is a hyperbola. Remember, the conic is given in standard form, so you must be able to complete the square to get it into the form that you see in this example. Since that is already done here, I can quickly see that this is a parabola simply because there is only one squared term. So it's a parabola. One squared term, parabola. Two squared terms, not a parabola. Because of that, I can find the vertex by identifying h and k. Remember, h is the x value, so this is the value that goes along with the x, and k is the value that goes along with the y, so my vertex is 5, 3, not 3, 5. This should be 5, comma, 3. Because 5 is your H, 3 is your K. So that's 5, 3. This parabola opens to the right because the y term is squared, which means it's horizontal, it's opening this way or that way. And if I take that value here, so I'm looking at for this right here, this 4p, okay, and that's always related to the number that's outside of the term that's not squared. So I know that 4p equals 8. So essentially I'm taking this number and I'm saying, okay, 4p equals that number. I divide both sides by 4 and I get p equal to 2, which is positive. So that tells me that it's opening to the right. It's opening in a positive direction. It's moving, opening this way. If it was negative, it would open to the left. So find the focus. I add p to the x value, which is 5. So the focus is the point 5, 5, because I added 2 to 5. That should be 7, 3, not 5, 5. Because h is 5. Here's my vertex. Remember, I add p to the vertex, the x value of the vertex. So I add 2, so I get 7, 3. If it asks for the directrix, then I would subtract 2 from 3 and get x equals 1. But I'm not subtracting from 3. Sorry about the confusion here. This number should be 5, because it's 5 here, and I'm subtracting 2 from that, so I get x equals 3 as my equation for my directrix. Okay? Alright, so that's all the information that we need. So I can use all that information to graph this just by putting all those points on a grid. So I know that 1, 2, 3, 4, 5, 6, 7, 8. I can get a rough sketch here. 5, 3, 1, 2, 3, 4, 5, 1, 2, 3. There's my vertex. I know this thing's opening to the right. I know my focus is it, so here's my vertex. My focus is going to be 2 higher than that, so here's my focus. My directrix is down here. So this guy, just a rough sketch, is going to look like that. Okay. Alright, 2 more things and then we'll be done. Just quick stuff on the other 2 conic sections. I know this video has a lot of information in it, and I apologize for that, but the best thing about it is this is the last one, and this stuff is, although it's somewhat difficult, it's not really that bad once you get used to it. So ask me lots of questions if you need to on this stuff. The last 2 I'll only ask you to identify. You may need to complete the square, but after that it's easy. So identify that it is an ellipse. Look for different numbers in front of the square terms. They will be added as well. In other words, there will not be subtraction in here. It'll be added like a circle. There'll be 2 square terms, and there'll be 2 numbers out here that are different numbers. If they're the same number out here, it's a circle. Okay? If they're different, then it's an ellipse. So as I said, notice that the values in front of the square terms are different, but they are added together. Therefore, it's an ellipse. I can rewrite this in this way, which is how it will typically need to be written. I am going to divide by 400. So I've completed the square, I've gotten it into this form. I see that I've got numbers in front of my squared terms, whether they're in parentheses or not, and that they're different numbers. They're different numbers I need to divide by whatever this number is here. Because ellipses and hyperbolas both have to be equal to 1 when they're written in their form. Okay, so I get x squared over 25 plus y squared over 16 is equal to 1. This is the equation for an ellipse. The center here is 0, 0. It's going to be very similar to the circle where whatever the center is going to be with the squared terms. Okay. I'm primarily concerned, like I said, with you being able to identify that it's an ellipse. Okay. Alright, last thing. Identify that it is a hyperbola, then you will see that there is a subtraction sign between the two squared terms. So here's an x squared, here's a negative y squared, that's negative. As soon as I see that negative with one of these two squared terms, doesn't matter if it's x squared or y squared, I know absolutely, without a doubt, that it is a hyperbola. Minus means hyperbola, addition with different numbers means ellipse. Notice that the x squared is positive, the y squared is negative. Hyperbola. Does not matter what form it takes. If there is a positive and a negative squared term, then it is a hyperbola. Minus with the squared terms, it's a hyperbola. Okay. So I complete the square on this thing, do my division, x plus 2 quantity squared over 5 minus y minus 5 quantity squared over 3, hyperbola, because of the minus, with the center with the opposite signs of negative 2, 5. Alright. I know there was a lot of information in this video. You guys are pretty much done. This was a long video, 22 minutes plus. Come ask me questions if you have any, and I'll talk to you guys later.